next piece that we're looking at is we're going to wrap up chapter 6. So we'll have like three sections or so covering all of this stuff. We're looking at logarithms. So I believe you guys got to some logarithms in Algebra 2. So you have kind of seen them before. But I am going to start back at the beginning, and just in case you've forgotten something, which I know never happens, but...
I don't remember.
Okay.
Oh, yeah, I do. Yeah.
So when you have a logarithm, that's this log means log. This is the definition. So you want to write that down. It means if I say y equals log base a of x, it's like saying a to the y power equals x. A log is a way of finding a missing exponent. The base and the argument. So the base is this little number. The argument is what you're doing the log of. Both have to be greater than 0. So, first thing, I want to make sure we are comfortable going back and forth between the two, because we're going to be seeing both notations now. So if it's an exponential, I want to change it to a log. If it's a log, I want to change it to an exponential. So when we write this, we put the log, we start. The base of this log, that subscript, is the same as the base of the exponential. So it would be log base 1.2. And you can always draw in these arrows. It's always going to make a circle. You go around the equal sign. So log base 1.2 of m equals 3. The log is equal to the exponent. B. We started with the log. We want to write the exponential. So the base of the log is the same as the base of the exponential. So it would be e. The log is equal to the exponent. So e to the negative 3 power equals b. You guys take a second and do C and D. We start with the base. So this would be 3 to the C power equals 5. D, when I put the log, what is my base? 3. So log base 3 of 9 equals 2. So make sure when you're writing this, that base is a subscript. The argument, like the 9, is a regular size number. Okay. All right. Let's see if we can evaluate some of these logarithms. So I want to see if we can get the answer. Log base 2 of 16. So we have some options here. I want to caution you. There is a log button on your calculator. It's base 10. So if I type in log 16 on my calculator, it's going to give me the wrong answer because it's base 10 and I want base 2. So we have two options for how to do this. One of them, if you understand what a logarithm says, you might be able to look at this and give the answer. Because an answer to a log is an exponent. This is like saying 2 to what power equals 16? 4. So the answer is 4. Now, the reason that works, if you set this up as an equation, you could say equals x, then if we solve this, we turned it into exponential form, that means 2 to the x equals 16. Isn't this the type of question we just had on our test? So if you get a common base, 16 is 2 to the 4, so x equals 4. I don't care. If you can look at that and write down the answer, that is fine with me. You don't necessarily have to show me that work. But if you can't just see that when you look at it, go ahead and write it out and solve it. So do you know what the answer would be on B? -3. Let's see. So if we set it equal to x, that means 3 to the x power equals 1 over 27. We need a common base. 1 over 27, what kind of exponent would move that to the bottom? Negative. 3 to what power equals 27? You were right. C. 0. It's like saying you can just write down 0 if you know it. If not, work it out. 2 to the x equals 1. So if we get a common base, 1 is the same as 2 to the 0. What would be the answer on D? 2. If you can't just look at it, work it out, but that's optional. So 5 to the x equals 25. Common base, 25 is 5 squared. And x is 2. Any issues so far? So I want to start solving equations with logs in. So here is our So I probably can't just look at this one and know the answer. What should we do? So it would be 3 to the second power equals 4x minus 7. 3 to the second is 9. If I add over my 7, 5 by 4. We will have to check on these problems. When you deal with logs, the base and the argument both have to be positive numbers. So we always just need to make sure that when I plug this 4 in, I get a positive. So 4 times 4 minus 7, that's positive, so we're okay. If that gave me a negative, what do you think my answer would be? No solution. And that will happen sometimes. So always verify that both the base and the argument are positive. The only negative you can see is what it's equal to. So B. So log base x of 64 equals 2. So if I want to rewrite this, to get rid of a square, we add a square root. If you add a square root, what do you have to do with that? But we know we need to check it. Can my base equal a positive 8? Yes. Can my base equal negative 8?
No.
No. this look like in exponential form? What do you want to do? I can't just add the
Flip it.
Okay, 1 over x squared. We cross multiply. So x squared is 9 over 16. How do you get rid of a square? Square root. With that we do plus and minus. Square root of 9 is 3, square root of 16 is 4. Are both of those answers possible? No. My base can't be negative. So 3/4 is my only option. Okay. So you understand the first part?
Yeah.
And then I just wrote it without a negative exponent. So a negative exponent moves that x squared to the bottom. Then I was trying to get rid of my fractions, so I just cross multiplied. So that's where I got my 16x squared equals 9. Then I was trying to solve for x, so I divided by my 16. Well, let's check. To the 3/4 power equals x. What is 16 to the 3/4? 4 through 16 cubed. Would you like that? Did you get it?
So you take the number that next to the ball, you take it on the other side. Put the number that's going down with the x.
All right. Not quite. Almost. So the next thing I want to mention, when you can and cannot use your calculator. So we will have some problems where we can evaluate on our calculator. You'll notice if I just give you a log and I don't write the base, it's assumed to be base 10, which is the same as the log button you see on the calculator. So if I just want you to find log of 46, you can type that in your calculator. So everybody make sure you know where those buttons are. So log 46, we should get 1.6628. Everybody get that? And the other log button on your calculator is what's called a natural log. That is actually a log with a base of e. They write it as an ln. But for now, if we want to use this, we just have an ln button on our calculator. Typically when you see this, it'll have an e with it. So we just type in this whole thing. Remember we did the e when we did the interest problem, so we have seen that before. So the ln is right below the log button. And when you push that, it opens your parentheses, and then you just type in 8 times e to the 6th power. We get 8.079.
So when we get decimal sign,
Yeah. Does everybody know how to use those on the calculator then?
You can.
because you use the base of x
And somebody has your variables they assign to the number, so it's quite easy. Okay. The last piece I want to do, there are a few properties for logarithms. that I want to get down in our notes. I may do like 1 or 2 brief examples of this today, and then this will be where we pick up tomorrow. So the product property says if you have a log of 2 things being multiplied together, you can do the log of each one added. And I'll talk more about the why tomorrow as well. Quotient property says if you have the log of things being divided, you can actually just subtract the individual logs. The power property says if you have the log of something to a power, you can actually turn that power into a coefficient.
What's the R?
An exponent. It'll just be some number. 2 more properties that are very closely related. So a log and an exponential, we are going to learn are inverses of one another. And we know that inverses cancel each other out. So if I have an exponential and a log with the same base, what happens is those actually just cancel each other and disappear altogether. So I would just have n for my answer. Or if the log comes first, the log of base a of a to some power. The log base a and the exponential with the base a cancel, so we just get that power. Again, tomorrow I'm going to talk a lot more about the why. I just want to get that part down in our notes today. I do want to look at just one slide. Just making sure you recognize this last 2 properties when they cancel each other and when they don't, because it looks a little weird when I have all those variables in there. So I just want to make sure you understand what I'm saying there. So if I gave us this problem, 2 to the log base 2 of pi power. So what do you think that would be equal to? Pi. The 2 and the log base 2 cancel.
So basically that's the same.
I have log base 0.2 of 0.2 to the negative radical 2 power. Log, does that cancel? And so you just get that power for your answer. So we have quite a bit of time, so about 20 minutes. There is a handout posted on Classroom. I'll give you time to do that and